Hi, hello, good evening. Welcome to JB Chem Tutorials. Today we are going to be discuss about what is chemistry. So, what is chemistry? So, chemistry is a branch of science. Branch of science deals with the composition, composition, preparation, preparation, physical properties, physical properties, chemical properties, and uses of matter. Uses of matter. For example, sand. Sand. For example, cement, chalk piece, etc. So these are the matter. It means the chemistry means it is a branch of science. It deals with the composition, preparation, physical properties, chemical properties and uses of matter around us. There is a matter around us, there are much more matter will be present. So, for example, sand. What is the use of sand? And then what is the composition of sand? What is the physical properties of the sand? What is the chemical properties of the sand? What is the composition of cement? What is the physical properties of the cement? What is the chemical properties of the cement? And what are the uses of the cement? As like it deals these all the things under the chemistry. And then this matter around us, the matter around us may be classified into two different ways. Two different ways. So we'll see the matter classification. So classification of matter. So the matter which is present around us, which will be classified into two ways of classification. Two ways of classification. One is based on physical classification. So based on the physical properties, its classification is called as a physical classification. Then chemical classification. Then based on the chemical properties, it is called as a chemical classification. Then based on the physical properties, they are classified into solids. Solids. And second one is liquids. Liquids. Third one is the gases. So, based on the physical properties, they are classified into solids, liquids and gases. For example, solids. For example, sand is the solid. And chalk piece. Either may be chalk, either may be powder, any powder. These are the examples for the solids. Example, liquids. Liquids. For example, petrol, water. These are the liquids. Gases. Gases. For example, air, nitrogen, oxygen, and etc. Carbon dioxide. These all are the example for the physical properties. Based on the physical. Then chemical properties. Based on the chemical properties, these compounds may be classified into two compounds. Based on the chemical nature, they are classified into two types. Those are the mixtures. Mixtures and pure substances. Pure substances. So, mixtures and pure substances. These mixtures again classified into two types. Homogeneous mixtures. Homogeneous mixtures and heterogeneous mixtures. Homogeneous means the some of the constituents which are dissolved homogeneously. For example, sodium chloride solution. Sodium chloride solution is an example for the homogeneous mixture. And coming to heterogeneous mixture. Heterogeneous mixture. Example, sand in water. Sand in water. Not equally distributed. In homogeneous mixture, the solute distributed equally is called as a homogeneous mixture. Then heterogeneous mixture means the solute will not distributed equally, is called as a heterogeneous mixture. Even though curry also heterogeneous mixture. Then coming to pure substances. Pure substances. The pure substances divided into two types. Two types. Those are the elements and compounds. Elements and compounds. So, elements are the pure substances which are made up of single type of the matter. Single type of the matter are called as elements. For example, hydrogen is an element and oxygen is an element. Nitrogen is an element and iron is an element, etc. Then compounds. Compounds are the mixture of elements. Mixture of elements which are made up of two or more elements. So the compounds and based on the compounds again classified into two types. Inorganic compounds and organic compounds. Inorganic compounds and organic compounds. So we're going to discuss about it again. So this matter again classified into the matter will be there are two types of classification. That is a physical classification. Based on the physical properties, the matter will be classified into solid, liquids and gases. So this is the classification. Then based on the chemical properties, the matter will be classified into mixtures and pure substances. And these mixtures again classified into two types: homogeneous mixtures and heterogeneous mixtures. And pure substances classified into two types: elements as well as the compounds. And these compounds again classified into inorganic compounds and organic compounds. Then we are going to be discuss about what are inorganic compounds, what are organic compounds. So, coming to organic chemistry. Organic chemistry. So inorganic chemistry. Organic chemistry and inorganic chemistry. So in the previously at the school time we knows that one study about either maybe about or about study about carbon compounds. Carbon compounds is known as organic chemistry. Organic chemistry. So, for example, this study about carbon compounds is known as organic chemistry. But what if, for example, H2CO3. H2CO3. It contains carbon, but it is an inorganic compound. Inorganic compound. H2CO3, carbonic acid. Carbonic acid. The question arises. Then coming to carbon monoxide. It is also carbon compound. It is also carbon compound, but it is an inorganic compound. Then coming to CO2. CO2, carbon dioxide. It is also inorganic compound but contain carbon. It means this study about carbon compound is known as organic chemistry. So all the carbon compounds are not organic compounds. The question arises. So coming to in the middle around intermediate, we will learn one more definition. That is a study about carbon gamma hydrogen compounds. Carbon hydrogen compounds is called as known as organic chemistry. Organic chemistry. Then they say as per their definition, for example, carbon and H2CO3. H2CO3, carbonic acid. Carbonic acid. It is also contain carbon and hydrogen, but it is not a organic compound. Then what is the exact definition of organic compounds? We'll discuss. Then coming to inorganic compound, inorganic chemistry. What is the inorganic compounds? Then this study about inorganic compound. Inorganic compound is known as inorganic chemistry. Inorganic chemistry. Then what is the definition? We will learn this one. So I will tell you how can we identify organic compound and inorganic compound. How can we differentiate organic compound and inorganic compound. So then I will tell one definition. The organic chemistry and inorganic chemistry. So study about carbon compounds. Carbon compounds is known as known as organic chemistry. And the organic compounds contains at least one carbon bond or carbon hydrogen bond. That means, so the organic compound at least exists with one carbon bond or carbon hydrogen bond. So if any compound existed with the carbon single bond or maybe double bond or maybe triple bond, it's belongs to organic compound. Then if for example if the CC bond is not there, then it must be either maybe CH bond exist with the CH bond. If in these two bonds any bond is not existed, that compound belongs to inorganic compound only. We will discuss. So, for example, we'll discuss about the examples. We'll discuss about the examples. For example, we say that one carbon monoxide. The carbon monoxide did not having any CC bond. CC bond is not there, and CH bond is not there. Hence, it is an inorganic compound. Then coming to H2CO3. H2CO3. It's called as a carbonic acid. So in which it did not contain any CC bond. CC bond is not there, and CH bond is not there. Hence, it is an inorganic compound. For example, so we'll see sodium oxalate. Sodium oxalate. It means oxalic acid, sodium oxalate. See, double bond O and O-N-A. Sodium oxalate. It did not contain CH bond. CH bond is absent, but CC bond will be present in this compound. So CC bond present in this compound, hence it is an organic compound. It means it is sodium salt. It means organic compound in the form of salt. It means sodium salt of organic compound. For example, one more is calcium oxalate. Well known about this calcium oxalate. So this is a calcium oxalate. So it is also organic compound, but calcium salt of oxalic acid. So it did not contain CH bond. CH bond is absent, and CC bond is there. Hence, it is an organic compound. So this way we can differentiate organic compounds and inorganic compounds. So the study about the carbon compounds is known as organic compound, but we cannot differentiate that organic compounds from the inorganic compounds. So if any compound said to be organic compound, it must be exist with at least one CC single bond or one CH single bond. If it is an existed with the CC single bond or CC bond or CH bond, it may be organic compound. The CC bond may be single bond, the CC bond may be double bond, the CC bond may be triple bond. So it's known as organic chemistry. Then coming to classification of organic compound. Classification of the organic compounds. So then we are going to be discuss about the classification of the organic compounds. So organic compounds classified into two types. Those are the open chain compounds and closed chain compounds. Open chain compounds and closed chain compounds. So open chain means the carbon bond will be open to each other. Closed chain compounds means the carbon will be close to each other. It may be forms a cyclic compounds. Hence they are called as a cyclic compounds. They are called as cyclic compounds. It means open chain compounds are cyclic compounds. Closed chain compounds are cyclic compounds. Then open chain compounds are acyclic compounds. Acyclic compound. So the organic compounds are mainly classified into open chain compounds and closed chain compounds. And these open chain compounds are also called as a acyclic compounds, and closed chain compounds also called as a cyclic compound. Then these open chain compounds again classified into two types. So open chain compounds classified into two types. Those are the straight chain compounds and branched chain compounds. So straight chain means the carbon. So straight chain will be formed. So branched chain means carbon, which will be carbon. So these like structure, these like compounds are called as a branched chain compounds. So example for this one is alkenes, and alkynes. So the example for this open chain compounds are the alkanes, alkynes. So these open chain compounds are classified into straight chain compound and branched chain compounds. Then coming to cyclic compounds. So this cyclic compounds again classified into this again classified into two types. Those are the homocyclic homocyclic or carbocyclic compounds. Homocyclic and carbocyclic compounds. And heterocyclic compounds. Heterocyclic compounds. We know that one. What is the homo? What is the hetero? Homo means same. It means these cyclic compounds made up of only carbon atoms. It means the carbon atoms, right? It may be carbon and hydrogen will be present, and the cyclic system will be made up of carbon chain. Is known as a homocyclic compounds. Then this in a ring system, it will be exist with the carbons with the other atom. The other atom is known as a heteroatom. Heteroatom. This is about the difference between homocyclic compounds and heterocyclic compounds. These homocyclic compounds, which is made up of only carbon cyclic compounds, and the heterocyclic compounds, which are made up of carbon along with the heterocyclic compounds. Then this homocyclic compounds again classified into two types. Again classified into two types. Those are the alicyclic and aromatic compound and alicyclic compound. And these alicyclic compounds are also called as a non-aromatic compounds. Non-aromatic compound. So how can we differentiate? Differentiate these alicyclic compounds from the aromatic compounds? It has some special criteria. So this is about the organic compounds. These organic compounds are classified into mainly two types of open chain compounds, and these open chain compounds are also called as a acyclic compounds, and one more is a closed chain compounds and also called as a cyclic compounds. These open chain compounds again classified into straight chain compounds and branched chain compounds, and these closed chain compounds are cyclic compounds again classified into two types: homocyclic compounds or carbocyclic compounds and heterocyclic compounds. And these homocyclic compounds are classified into alicyclic compounds and aromatic compounds. Then we are going to be what is the difference between aromatic compounds and non-aromatic compounds. So if any compound, so for example, we will discuss about the aromatic compounds and cyclic compounds, aromatic or not. We are going to be discuss about it. So for example, so it may be aromatic compounds. Aromatic. So how can we say that the compound is an aromatic, which is the most important one? And if any compound it's said to be aromatic, it must be follow some rules and regulations. So first one is so it must be cyclic in nature, cyclic structure. It must be cyclic structure, and it must be a flat structure. That means it must be cyclic in nature and it has a flat structure. Next, it must be contain conjugated system. Conjugated system. So what do you mean by conjugated system? And it means alternative double bonds. alternative double bonds. Then third one, it must be satisfies the Haeckel's rule. Either maybe Haeckel's rule, Haeckel's rule depends upon your pronunciation. What is the Haeckel's rule? That equals to Haeckel rule equals to 4n plus 2 pi electrons. Pi electrons. So what is the n? N equals to number of rings. Number of rings. For example, n equal to 1. N equal to 1 and 4 into 1 and plus 2, that equals to 6. If the structure only single ring, it must be contain 6 pi electrons. For example, n equal to 2, then in 4 into 2 plus 2, then it must be contains 10 pi electrons, 6 pi electrons. Then n equals to 3, 4 into 3 plus 2 and 14. So it must be contain 14 electrons. So this is the system. So it must be cyclic in structure. It must be contains conjugated system, and it must be it must be obeys the Haeckel's rule, that equals to 4n plus 2 pi electrons. So we'll discuss some few examples for it. For example, we want to draw some structures and we will differentiate it. For example, this is a cyclic structure. I am writing this is a structure, and one more structure is a so these three I'm going to discuss about these three. So for example, single bond, double bond, single bond, double bond. So it as cyclic in nature. First one is a cyclic structure. It has cyclic structure, and it has a flat structure. So it satisfies this one. Next one is an alternative conjugated system. Single bond, double bond. So it has a conjugated system. Then coming to, it must be satisfies the Haeckel's rule. So only one ring is there. Then 4 into 1 plus 2. So it means 4n plus 2 electrons. So then 4 ones are 4 plus 2, that equals to 6 pi electrons. If it is as 6 pi electrons, it may be aromatic. For example, we will calculate. So it has this one, So one double bond equal to 2 pi electrons. 2 pi electron, 1, 2, 3, 4. So it has the 4 pi electrons in a structure. It means it not satisfied the Haeckel's rule. So Haeckel's rule not satisfied. Hence it is a non-aromatic compound. Or alicyclic compound. Next, coming to, we will discuss about this structure. So it has cyclic structure. It is a cyclic structure, and it has a flat structure, but double bond, single bond, double bond, single bond. So it not conjugation not there. And 4n plus 2 electrons. So for example, it is an only one ring plus 2, that equals to 4 plus 2, that equals to 6 pi electron. So if it is as 6 pi electrons, 6 pi electrons, it may satisfy the rule. So for example, when we count it 1, 2, 3, 4, so it has only 4 pi electrons. So it satisfied this rule and it did not satisfy this rule and it did not satisfy this rule, hence it is an non-aromatic compound or alicyclic compound. Alicyclic compound. Then last one we will discuss about last structure. So for example, this is a structure, we don't know it is an aromatic or not. So it has cyclic structure, cyclic structure. Cyclic structure, and next one is it is as flat structure, and it has conjugated system. Conjugated system means double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond. So it satisfied conjugated system. Conjugated system. And 4n plus 2, for example 4n plus 2 pi electrons, 4n plus 2. So 4n plus 2 rule. That means how many number of rings are there? Only one ring is there. So 4, 1 plus 2, that equals to 4 plus 2, 6 electrons. So if it has 6 pi electrons, and it is aromatic. For example, we will count 1, 2, 3, 4, 5, 6. So 6 pi electrons are there. So it has cyclic structure, it has flat in nature, and it has a conjugated system, and it has conjugated system, it has 6 pi electrons, hence it is an aromatic compound. Aromatic compound. So we'll see one or two more example for the aromatic compounds and non-aromatic compounds. For example, so we'll see. So this is an two more example for it. So it has so it has cyclic structure, and this structure must be structure is a flat in nature. So it is a cyclic structure, it has flat in nature, and conjugated system. That means double bond, single bond, double bond, single bond, double bond, single bond. Here double bond, single bond, double bond, single bond, double bond, single bond. So it's a conjugated system. Conjugated system will be present. It has a conjugated system, and 4n plus 2 electrons. 4 into plus 2 pi electrons. That means how many number of rings are there? 1 ring, 2 rings. So 4 into 2 plus 2, that equals to 4 2 ja 8 plus 2, that equals to 10 pi electrons. So we'll see, if it has 10 pi electrons, it may be aromatic. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 pi electrons are present. So it has a cyclic structure, flat in nature, and it has a conjugated ion system, and it has 10 pi electrons. Hence, it satisfied the alkyls rule. Hence, it is an aromatic. Aromatic. Then coming to this structure. So it has cyclic nature. It has cyclic structure, and it is a flat in nature, and it has, for example, see, double bond, single bond, 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 double bond. So it has conjugated system. Then it must be satisfied Haeckel's rule. So as per Haeckel's rule, 4n plus 2, that equals to 4 into, how many number of rings are there? 2. So 4 into 2 plus 2, and 8 plus 2, 10, that equals to 10 electrons. If it is as 10 pi electrons, it is an aromatic. Then we'll see 1, 2 electrons are there, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it has 12 pi electrons. So it has two more electrons are there, hence it is an non-aromatic. So this is about what is the chemistry, and then what is the organic chemistry, what is the exact definition of organic chemistry, and classification of organic compound, how can we identify the organic compounds, and how can we differentiate organic compounds from the inorganic compounds, and how can we identify the organic aromatic compounds from the non-aromatic compounds. If you like this video, please share and like to me. If you want to be if you have any doubt in the comment section, you have to write the topic name. I'll explain it. If you like it, you can like it. Thank you all.